When we are doing the ray tracing in the case of spherical mirror, or in the case of plane mirror as well, or in the case of lenses, okay, whenever we are doing ray tracing, there are certain rays which are easier to trace than the other rays. Okay, so the object of ray tracing is to take an object, take some light rays emanating from the object, make them strike the mirror, and then see where the actual image would be formed. Okay, so we have to take only two rays to understand where the image would be formed, because the image would be formed at the intersection of those two reflected or refracted rays. Okay, so in the case, the certain whenever we are doing this, there are certain rays which are easier to trace than the other kind of rays, and those rays are known as principal rays. So principal rays are those rays which are easier to trace in case of ray tracing. Of course, in the case of concave mirror, okay, so this we are going to draw the concave mirror and try to understand where these rays are. Okay, see, the most simple case is the principal ray that passes or comes from center of curvature. So this is our center of curvature, and there is a ray which comes from here. Okay, let us assume that it is going in this direction. Now, because this is the radius of this entire sphere, the angle at which this ray would be incident would be 90 degree, and therefore it would be reflected back at the same angle. It would be reflected back at the same angle, and therefore tracing this ray from the center of curvature along the principal axis, if we draw a ray, then tracing this ray becomes very easy. So this is one of our principal rays. We are always going to use this particular ray all the time. The second ray that we are going to look at is this one. Again, very simple. This ray which incident on the pole of the mirror at an angle theta would be reflected back at the same angle theta. Okay, why? Because angle of incidence has to be the same as angle of reflection. So that is the second of our principal ray. We are going to make a ray incident on the pole of our mirror. Okay, so same thing we'll do, the same exercise we'll do in the case of convex mirror as well, but in the case of concave mirror things are very simple. So that is our another one of our principal rays. Now there are two other principal rays which come from the fact that whenever we have a mirror, okay, there is a point in the mirror known as focus. And what is the definition of this point focus? What is the definition of this point? Now let us look at the definition of this point. By definition, the rays which are coming from infinity parallel to the principal axis always pass, reflect back, and pass through the focus. That is the definition of the focus. Rays from infinity converge at the point when they are reflected from the mirror, convex or concave, and that point is known as focus. So by definition, if I trace a ray from infinity, it will converge, it will pass through this point, it will intersect this point F, the focus, and on the principal axis. This is this one. Okay, optical axis or principal axis is one and the same thing. Now the last of the four rays is that if I were to pass a ray through the focal point, so now I am going other way around. Okay, so now I am going like this. If I were to pass a ray in this direction from the focus, the ray is going in this direction, then it will hit the mirror, get reflected, and it will go parallel to the principal axis. Okay, it will be reflected parallel to the principal axis. Okay, so there are two principal rays which are related to focus. One ray which is emanating from the focus, one ray which is actually coming from infinity and then after reflection passing through the focus. These are our two principal rays right here. The third principal ray is the one which is coming from the center of curvature. It is going straight along the principal axis. The last one is the ray which hits the pole at an angle theta. It will be reflected back at the same angle theta. Now we can do the same exercise, the very same exercise in the case of concave mirror. It should not be in the case of convex mirror. Sorry, we did for the concave mirror. We will have to do the same exercise in the case of convex mirror. So let's just do that very quickly. We'll do it. So this is my convex mirror. I have put it like this, and this is our principal axis. Okay, so this is our C, our center of curvature. This is our focus, and this is our pole. Okay, so let us first draw the line which starts from the center of curvature. It goes like this, and then it comes back like this. That is the first principal ray. The second principal ray would be this one. It is incident at an angle theta, and it is reflected back at an angle theta, incident at the pole of the convex mirror. That is this second principal ray. The third principal ray, like we discussed before, is related to the focus. So now we draw that one. So it is incident right here. It is parallel to the principal axis. It is incident on the mirror. After reflection, it will definitely go through the focus. So this is our third principal ray. The fourth one would be going in the opposite direction. It will go through the focus, hit the mirror. Okay, it will go through the focus, hit the mirror, and then after reflection it will travel parallel to the principal axis. So again, if you want to note down these 4 rules, you can. I move to one side. Very important, these 4 principal rays. Okay, the fourth one is the one that was hiding behind me, so I moved to one side. So definitely note this down. Very important. Whenever we are doing ray tracing, we will always consider these 4 principal rays, both in the case of concave as well as in the case of the convex mirror, and this will be again very useful for solving numericals. Thank you.